Swayam Prabha. Digital India. Educated India.
Welcome to lecture 25, regenerative circuits. This is under module 6, hydrostatic transmission system, but I would say hydrostatic transmission system, as I described in the last lecture, is comprises of pump and motor together. There will be pump unit, there will be motor unit, they will operate one to each other, and this might be open circuit, maybe closed circuit. In comparison to that, or if we in terms of that, say the regenerative circuits is mostly that piston, cylinder and valves operated definitely by a fluid power system, where the pump and other components are there, and this may be put into the other module where we discuss about the hydraulic circuits. Anyway, for the distribution of lectures under different module, I have put in this module, and this you will find very interesting. Now, what it is? If we consider any hydraulic cylinders with differential areas, mostly you will find that one side there is rod and other side there is not, the piston rod is not there, and these are quite common in many applications. The full area and the annulus area make circuits possible in which oil from smaller area can be fed straight back into the larger area. This means that we can mix up this oil with the oil in. You will find that mixing in the other way is not possible. We can mix only in this way, and that obviously increases the speed of the piston. These type of circuits are termed as differential circuits, bypass circuits, regenerative circuits, and circuits with return oil recovery. Various names are there, but maybe regenerative circuit is more lucrative. So, I have given the title regenerative circuits, and I shall discuss how it works and what are the possibilities of using this circuit and system for variety of output. Now, in this figure we will find a double acting cylinder, linear actuator motor, we can say linear actuator or motor of unequal area, and the details of the force in the system. Now, I would say that you should remember this term double acting. Double acting means it is acting in both way. It is it can do work while it is moving in forward directions, also it can do work while it is in the return motion. However, in most of the cases you will find the return load is usually less, it mostly less. Now, I have shown the forces acting here. Now, what is there? say we are supplying, say let us consider it is moving in this directions, okay, and it is also moving a load due to which FL is the force acting in this directions. So, there must have some pressure which ideally we can get this force divided by this area P, that pressure is there. This side if we connect directly to the tank, then only pressure will be some resistance to flow the oil, otherwise there should not have any pressure. So, to say we can say this pressure, to find out this pressure we should calculate this force, then it must be equal to this force minus this force, where this force is the annular area A2 into the pressure PR. Let us consider it is going back to tank and there is no resistance. So, this pressure is 0. Okay. Now, what we can consider that there will be some friction force. This friction force always will act in the direction of opposite to the direction of motion. So, this will be added to the load it is handling. So, that this means that to calculate the P we have to add this load with this load and then divide by this area. Okay. Now, where that A1 I have already discussed, it is the full piston area. You can simply, if you know the cylinder bore diameter, then from there you can find out the area A1. Now, A2 is the annulus piston area. Remember, this is this full area minus this rod area. Okay. Fs is the friction force offered by seal here. Also, there will be some friction, but this friction will be severe than the friction here, because as it is a double acting, there is also seal. So, while we are considering the friction, we will consider this plus this friction. It is apparently written here only, but this is the component of this friction force and friction force at this cap also. Fl is the applied load and P is the pressure on full area and PR pressure in the return line. Now, we can equate this force P into A1, that is full area, must be equal to FL plus PR into A2, whatever may be this pressure, plus Fs is the friction force. Okay. For understanding the purposes of the regenerative circuit, how it works, let us assume that friction force is negligibly small, and we shall also equate this at no load. Then equation 625(1) becomes P A is equal to P R into A2, or in other words, that just to understand that if we would like to generate a pressure here, what we can do, we can put a restrictor here. Say we can connect this path to a pressure relief valve, which is set a some pressure, maybe up to this pressure. In that case, what we can do, what we will find that this will generate a pressure, say any pressure, this pressure relief valve set at any pressure, say 5 megapascals. Then here must be 5 megapascal pressure to be generated for the leakage. Then whatever P is required here, that also can be calculated. That means, at that condition we can write down this equation, or in other words, if some resistance is put here, then we can generate the pressure by creating the pressure here. Now, that pressure again we can calculate directly from these equations. This all equivalent sign is given to estimate this pressure. Okay. Now, here A 2 is less than A 1, hence P r must be greater than P. That means, this pressure will be higher than this pressure. This means that we can directly allow this flow to mix with flow in here, because if it is a less pressure, then the flow will try to go in this direction. Of course, there is a question of displacement. If there is no space to flow, then there will be no flow, but once the pressure is higher than this side, we can mix up the flow. So, that much yet sure, but still we do not know how to engineer it. Thus, the pressure developed in the return line annulus area for a given pump inlet pressure is more than the pump inlet pressure. It is the advantage of differential area. If the same rod to be also in these directions, in some arrangement it is like that, in both sides there are piston rod of equal diameter. In that case, we will not have such facilities. It makes oil flow possible from return annulus area, which I have already described. Now, let us calculate the flow. Now, this figure 2 6.252 shows the stroke and the flow equilibrium. This means, so stroke length is this much. For that, we will estimate what is the flow here and what is the flow here, and that we say that the equilibrium in flow. And if we write in the form of equations, this will be calculated first considering the time. We shall consider that T 1 be the time taken to travel stroke length x for this motion in the direction, outward direction. Okay. And Q is the flow. Then we will estimate what is the Q out. The Q out definitely is A1x. A1x is the total volume, right, for the x stroke in this side, and that divided by T 1 is the Q out. Okay. T 1 is the by this time, which is the volume of oil pumped out through the annulus ring, annulus area A 2 during the time. Okay, the volume of oil pumped out through the annulus area A 2 during the time A 2 x. I think this equation I have written wrong. It is, this will be Q in. Q in is A 1 x by T 1. Okay. Now, A 2 x we will estimate. In regeneration, the return oil from annulus area is mixed with the pump inlet oil for extension stroke. Okay. Now, we will see that. Let in case of regeneration, the time to travel x stroke is T 2. That means, if we now mix the oil, definitely this time to travel will be different, because the original flow Q in is there as well as Q out is there. Now, this flow we can calculate. Now, the new flow, when this Q out is mixed with this, then the Q in whatever it was there, it is there, and plus A2x is the flow out from this side, the annulus side. Time taken is T2. So, this must be flow out, and that is mixing with Q in x, and that must be equal to A1 x by T2. So, in earlier equation, then definitely this equation was I have written wrong, that will be Q in. This is very simple equation, but if we now equate for this area and time, what we find that A1 x by T2 is equal to A1 x plus T1. This is equal to A1 x by T2 minus A2 x by T1. So, this is coming from the equation 6.253. So, this must be Q in there. Okay. Now, further equating, we get T2 with T1, definitely T2 will be less, is A1 minus A2 by A1, and that is T2 is equal to T1 1 minus A2 by A1, and as A2 is less than A1, therefore, T2 will be less than T1. That means, we are getting additional speed by mixing the oil. Okay. Hence, in regeneration the velocity increases, the time of travelling into stroke decreases, x strokes. This is the x length, x stroke decreases. Okay. For an example, if we take this A2 by A1 is equal to 0.5. Now, remember here the A2 is the annulus area. This means that when A2 by A1 is equal to, definitely the diameter of the rod is half of the total area of the pistons, but that does not mean the diameter is half of that. I have seen that while calculating, many student, many engineers, they make a mistakes, they consider the diameter is half and they arrived into wrong result. So, just remember this area is half, not the diameter. So, what we get T2 is half of the T1. So, in simple circuit, whatever the time taken, in case of regenerative circuit, we have half the time to travel. Now, we will look into the applications. As the fluid from the smaller area of the cylinder is effectively being pumped back into the system, this leads to either higher cylinder velocity or reduced pump flow is required for the same cylinder velocity. Now, here I would say that instead of cylinder velocity, we can write the piston velocity. Anyway, this means that either the working cycle or the overall cost of the system is reduced. Definitely, we are recycling the oil. Now, this cylinder velocity may be in the with specific reference to where this piston end is fixed and this is being moved. In some cases, it is like that, when this is carrying a particularly a table or other things, so cylinder moves. So, perhaps that is why it is written the cylinder velocity. Now, the fluid is supplied from an accumulator system. The overall energy input into the system is once again reduced, Along with this regenerative, sometimes an accumulator is also used, and there you will find that we are getting much faster speed. You can think of one application directly here itself, say for example, the shaping machines or planar machines, where the return stroke is much higher. This has another applications, that is control velocity, because we are now moving something. Say for example, if you move a pen is like this, just pushing like this, then you will have less control facility than if we move like this. You are putting a pressure here, then you are moving like this. So, control point of view also regenerative circle will be better. It is often required to move a single rod cylinder at equal speeds in both the directions. So, if you find that for half area, if you allow to the oil the same flow rate, whatever the speed will be in return stroke, the same speed will be in the forward stroke if the oil is mixed. So, with this also we will get equal speed in both the directions, that is another advantage. This is easily achieved with a regenerative circuit by utilizing a cylinder with a 2:1 area ratio, what I have mentioned now. In this case, the annulus area is equal to the rod area. Okay. A further application for regenerative circuit is found when the force being applied by a cylinder travelling forward must be severely limited. That is, if cutting tools or molds would be damaged by the application of high forces. That what I mentioned. So, if you move this piston in this directions with force in both the directions, it will have much better control. Another point to be mentioned, in the high speed mode, both sides of the cylinder are under pressure and only the piston rod area is available to drive the cylinder forward. This means that you see, if the pressure is acting over here, now when this is mixed, definitely pressure both the side has to be equal. Now, in that case, real area available to tackle this load is only this much area. Okay. So, that means you will find that in that case pressure is equal to force divided by simply this rod area. Okay. So, this means that you are handling a smaller load, holding the piston with higher load. This is another I would say this in another form of presentation, the facilities in control. Now, we will think of the circuit, how we can make the different circuit in regenerative process. In general, the circuits may be divided into two groups, those allowing only one forward speed, high speed, and those in which a changeover may be made high speed, low speed, etc. So, in one application for regenerative, simply we are mixing the oil for forward motion, simple is and while it is written only, then it is a simple circuit. Okay. But with the different type of valve and the circuit, what we can do, we can make this system, this one cylinder to move at a normal speed, then regenerative speed, etc. We will discuss about those circuits. The changeover can be made automatically or may be depending upon the piston position, pressure, time or any other required signals, or it might be manual, simply manual, or it might be automatic or semi-automatic. Many things are possible with the application of other controls. maybe hydraulic, maybe pneumatic, may even be electronic. Various circuits are explained in the next slides. Now, this circuit we will discuss few circuit. In this circuit we have used two numbers of DC valve, 2 by 2 DC valve. You definitely you understand, as you know the symbols, the 2 by 2 DC valve. Then how it operates? Valve 2 operate for forward motion, that means and valve 1 operate for return motions. Let us say valve 2 is engaged, that means the flow is going like this. Okay. This is closed. So, this means that oil is being mixed, the only regenerative. Now, when valve 1 is engaged, that means this line is connected and valve 2 is closed, that means it is in this positions, then oil is coming back to the tank from the full area side and oil is going to the return side. That means normal return and regenerative forward motion. So, this is the simplest circuit, but we have used 2 by 2 DC valves. Now, let us consider another case that both the valves are open, that means connected. In that case what will happen? Tell me, in that case cylinder will move in which direction? The answer is it will not move, because oil will always flow to the less resistive path, and that is definitely the return path. Oil, if this is connected and this is connected, oil will simply go like this and it will go back to the tank. It will not operate this one, because there is some resistance and some load is there. So, in no case this will move. So, that means this is not a hydraulic operation, this is a simple case of oil is flowing, and in fact, that can be done, because if you do not want any operation here and the pump is still on, then oil will go back to the tank, not through this. So, that will act as an open circuit, open center valve. So, you can design the circuit in this way. Okay. Valve 2 mixes pump input flow and flow from annulus side, achieving high forwards motion. Now, if we go to the circuit 2, in that case what we have used? A DC valve again, and that is 3 by 2. Why 3 by 2? This is 3 port, there are 3 port, 2 way, 2 position, or you can say 3 way 2 positions, 1, 2, 3. So, 3 by 2 means 3 way 2 position valves, always the number of ways is at the beginning. So, 3 by 2 DC valve. Now, let us see what happens. Valve is in neutral condition, retraction takes place. That means, if we put the valve in this direction, this is the neutral position, it has been say position 1, instead of neutral we can say this is the position 1, this is the normal positions, and as the spring is there, means if you do not operate the valve, it will be here by the with the help of the spring. Now, in that case oil is going in this directions and oil from this side it is coming back to the tank. Okay. Now, what we do? We operate this to the other positions. then there is no intermediate position, only full forward or full back, and in that case, that means if it is in these positions, then oil will go here and this oil will also be mixed. That means this is having one regenerative and one return positions. What will happen? We do not have any other positions. In comparison to the first circuit, there only we get two possibilities. There is no three possibilities, the third possibility, and in that case what will happen? When it is fully retracted, oil has to go back via the pressure relief valve. So, that means it is, you see that closed center, it will act like a closed center valve in normal conditions. Normal conditions means, again I would say, while you have your valve is in this position, if it was fully forwarded, then it will come back to its retract position, and then this will, the flow will bypass via the pressure relief valve. Now, circuit 3. In this case, before writing this, what is this valve? 4 by 3 valve. This is 4 by 3 DC valve. Okay. Now, when the spool is in neutral condition, all the ports are blocked. So, there is no motion. During the right solenoid operation, regeneration takes place. That means, here the in the valve itself, the regenerative circuit is made. It allows the mix this oil with this one, but when it is this in the other positions which I have not shown, that is, that will give the normal return. Okay. Now, if we come to the circuit 4, in that case, again this is a normal valve, 4 by 3 valve, DC valve. This is closed center valve. Okay. Along with that, we have added something to make it regenerative circuit. What we have added? A shuttle valve, and along with this 4 by 3 DC valve, the oil returns to the full bore outside the directional valve by the shortest possible path. This means, when we in the right hand side of this valve, then definitely this oil flow is going in these directions, and oil coming back from this side, as there is a shuttle valve, this shuttle valve will automatically mix with this one. It will not allow the oil to go in these directions. So, this valve is such that it will come and it will flow like this, it will not come in these directions. Sorry, this is but if you see this in other positions, left hand positions, you will find this oil being the forward the return stroke is in normal using this sign, this symbol. Now, in this case again what we find, the same valve, but instead of shuttle valve we have used two check valve, 1 and 2, and also there is a flow restrictor. So, definitely this is having, say, regenerative plus something, maybe we can expect from that. We can analyze this using this one, but let us see what are the valves are there. So, 4 by 3 DC valves are there, 2 check valves, and an orifice which helps oil bleeding to tank when the load increases. What happens? Let us see. Now, let us connect the right hand side. In that case, then oil is going like this, and oil is coming from here. This will now being mixed, because here the pressure will be more. So, it will be mixed here, but when it will be mixed, then pressure is equal. It by no means it can go in this directions. Now, what is said, if there is more load, suppose the load is increases, how it can happen? We are using for say metal cutting process in a machine tools. Due to some reason the load is increased. When the load is increased, in that case automatically there will be increase in pressure, because this pressure minus this area minus this area, and only we are getting this rod area for generating the force, and obviously there will be more pressure, and due to that you will find that this flow also taking place through this path, and automatically the speed is reduced. Okay. Now, if we bring the valve in this position, then the oil is going to only this side. It also can flow in this way, provided the load is more. In case the load is more, then it will flow through this, otherwise it will not flow. If even if it flows through this, it is again will be mixed with this, it cannot go to the tank, whereas this side oil is directly go back to the tank. So, in that way, using this we can have an additional advantage, that with the increase in load there will be the bypass flow and the bleeding flow you can say, and the speed will be automatically reduced. So, this is regenerative and bleeding mixed together. The increased pressure allows more oil flow to the tank through the orifice, thus reduce the load speed. Now, we have discussed only 5 circuits. Now, there what we will find, there are another 6 circuits, which is from 6 to 11. This will be shown now, and this is mainly for your exercise. So, there is not much explanation is given. From there you have to understand how these circuits are being operated. Now, in some of those circuits combination of valves are used. This is not a single valve, you will find the few valves are being used to have particular function. We shall explain. Now, let us consider the circuit 6. The valves can be operated for stopping, fast forward, slow forward and return motions. What we find, we have these are what type of valves? 2 by 2 DC valves. What we find, that there are identical 2 by 2 valves. So, this is A, B and D, these are same, basically same, only if you have just put in the opposite direction, considering that oil is only allowed to flow in one direction. So, you can put the valve in other way, then it will go in these directions, and this and this identically same, this is also same, but put in the other way. Okay. But there is one valve at least which allow flow in both the directions. Now, and the pump is connected to these 2 valves, whereas return lines are connected to valve A and D. Okay. Now, operation and sequence and result of actions for circuit 6 are described below in the tabular form. Let us consider the operation is that valves B and D are made on. On means these are connected. Okay. A and C are remained off. Okay. When piston is at left hand side, then what will happen? Piston will move forward, that is right hand side. We have connected this path, we have connected this path. Okay. So, oil is D are made on, that means oil is going through this and oil is going back to the tank through valve D. So, normal forward and backward operations in that case. Okay. Now, next the valves A and C are made on and B and D are off. Then piston will move backward, that is left hand side. So, what we have made? We have made A and C on, this is on as well as A. So, oil is going in these directions, this is closed. So, oil cannot flow in these directions and oil has to go back to the tank. So, again normal return operations. Now, valves B and C are made on, B and C both these valves are made on and A and D off. The piston will move forward, that is right hand side, with faster speed than in one. So, this must be regenerative. Okay. For other combination of valve piston motions are unpredictable. That means, if we now other than this, if we connect in other maybe C, D or any at random, you will find that this is not moving, or it may move in one direction depending on the resistance here less than the resistance for the flow through any valve return to the tank. So, basically we should say this unpredictable. This means that while you are given a circuit like this for your self understanding, or maybe you have to in a question form you have to answer, you have to make a table like this, you have to look into all possibilities and you have to write down what are the operations, what are the motion possible with that combination of the valve. Now, if I consider the other circuit, that is for self exercise, and let us consider this circuit. So, regenerative circuit the 7, here we have used 2 3/2 DC valve, 2 3/2 DC valve, and both are connected like this. Now, let us consider that this side, this when this connection is shown, right hand side is the neutral conditions and the other connection is the operational conditions. Now, both the valves looks same and they are same. Now, if we let us consider B is in this position and A is connected, that means we have connected this way, then what will happen? Oil will go to this side and it will be back through this valve B. This means normal forward operation. So, you make a table and you write this for A is on, B is neutral position. It is not actually off because this is connected, you can say this is off. It has two positions, this is automatically it will be in this position due to the spring. Okay. So, this is not operated and A is operated, in that case normal forward motion. Now, let us consider A is closed or on this its neutral position and B is open. So, this is normal return. Now, what other combination may be? So, both are closed, that means what is shown there. In that case, the flow is going to the tank, no operation is there, it is going back to the tank to the pressure relief valve, there must have a pressure relief valve. Okay. Now, if I connect both A on and B on, in that case flow will be mixed. So, there will be fast forward motion and regenerative circuit. So, make a table and write in this form, right. Now, we are taking another circuit. In that case, what we have taken? This is a 4/3 valve, but center is specially connected. This is neither closed center nor open center. Only thing, the tank side is closed and other is as if this showing the regenerative path. In that case, in neutral, this is definitely a neutral position. In neutral condition, regenerative forward motion is there, but for the other two connections there will be normal, one is return motion and another is forward motion. Now, let us consider by due to some reason it is here in this position, the rightmost position, and then this regenerative circuit is on the neutral positions. When you have brought it in the neutral positions after these operations, then what will happen? Only then there will be the flow through the pressure relief valve. You can write this note, say while you are trying to answer this, what will happen to this section, you can write that in that case it will be, there will be flow to the tank through the pressure relief valve. We are distinctly getting one normal forward motion, one regenerative motion and one return motion for the 3 valve positions, but it might be while it is in, say suppose it was in this side and then we have bought this, we have given this connection, it was here and again we have given these connections. In that case also what will happen, this oil is trying to go here and oil is trying to come back here, but this will go back to the tank. So, this you have to mention, but in this case there is no such position, that unpredictable position is not there. Suppose this piston was at the middle positions and then one of them you have connected. So, at least one operation will be there, it is not unpredictable in case where the flow was directly being connected to the tank in comparison to other cases. Now, we shall consider the circuit 9. In that case, this is 4/3 closed center DC valve, normal valve, and what it is? This is 3/2 and neutral position, it is connected in this way. So, what will happen if this is in neutral position and this is connected, then there is no operation, because oil is going back to the tank, no operations, but definite, not unpredictable, right. Now, if it is connected in the this side, the right hand side, then oil is, so then this path is connected and this path is connected. Now, what will happen? This oil will go to this side, but this oil also go to this side, or you can say then only this regenerative, that means it is connected like this, regenerative. No, it is like that, you think twice, say this is connected and this is connected, then oil is going to this, this is moving, and also this connection is there. So, this cannot go back to the tank, oil is going there and oil is going here. So, what will happen in that case, tell me, it both sides are connected. So, oil can go both side. So, possibly this will act as an, but there is no connection in between. So, there is no chance of regenerative circuits. Okay. Now, let us consider that this is undecided. Now, what happens? We have connected this and we have made this connection. In that case, oil will return to this tank. So, this is normal forward operation. Okay. Now, let us connect this one. In that case, oil is going to this and oil is coming back through this, and this is in neutral positions. So, in that case, with this connection and in this neutral positions, this normal return. Now, with this connections and this connection, then oil is coming through this path and this is closed. So, oil is coming to this path, that means oil is not going here, and then it is being mixed with this one. So, regenerative. So, one of that is unpredictable, and with this connection we can have, with this connection and this connection we can have regenerative. So, please you should make a table and say, I would suggest. So, usually the pattern of questions are like that. This circuit will be given, you have to say what will be the operations. So, please make a table and you analyze, your self analysis is required for this. Now, we shall consider another circuit, that is, in that case what we have used, this is 4/3 DC valve closed center and this is 2/2 valve. In that case, let us consider this is in neutral position. So, obviously, as it is a closed center, there is no flow, no operation. Now, if we connect into the right side, then this will be connected and this path will be connected. Now, once this is connected, but this is closed and this is closed, then no operation, again no operations. But with this connection you can operate this. Suppose you have operated this one, then oil will go here and oil will try to go this side. In that case, oil will go this side and oil from here will return through this path. Oh, sorry, oil is coming back from this path, because this is connected, okay, and oil is going through this path. So, this is normal operation, no mixing, it is not being mixed. Now, with this connection we connect A and B is closed. In that case, what will happen, this oil will go to this side and also it is coming like this and oil will be mixed. So, A is operated means then only it is regenerative, right. Now, let us consider this is connected and both A and B are also connected. In that case, oil will go like this, it will try to go in this way and it will go in this way also, and as it is connected, this oil will come back to the tank, no regeneration, it is a oil will directly go back to the tank. Now, let us consider this connection C. If the C is connected and then let us consider B is closed, A is closed, then no operations obviously. Now, this is I would say this is going like this and this connection is there. So, no operation. Now, if B is open, then oil is going like this and trying to go this side as well as this side, but this it cannot go. So, it is normal backward operation. Okay. Because this connection is there. So, normal backward operation. So, this means that by combining these two valves we can get normal forward, regenerative and normal backward, but only for the cases when A and B are open, then there will be no operation, unpredictable. So, this you have to clearly mention for which operations valve combinations that there is no unpredictable, that you have to mention. In some circuits you will find that there is unpredictable cases, in some circuits there is no unpredictable cases, there will be some operations. Now, in case of 11, what we find that the pump is connected to, again this is by 4/3 valve, only on the return side there is one 2/2 valve, and in that case if it is in the neutral position, no operations. If it is in the right hand positions, then oil is going to this, and as there is a check valve, oil is going like this and oil is coming back to the tank, no regenerations. Okay. We have connected this and no regeneration. Now, we have connected this and we have operated also this valve. In that case, the oil is going like this, oil cannot come back to the tank and it is being mixed. So, regenerative. So, right hand side and this operation putting into these positions, there will be regenerative. Now, we have connected this one. So, oil is trying to go in this directions, okay, and oil from here is cannot go this way, it is going to this path. Okay. Now, what we have done, we have operated this one, then this oil is trying to mix with this side, but there is no way. So, it can only circulate, it is trying to circulate within this path. This means that it will normal return, there will be normal return, because this oil can circulate there. Now, if it is circulate means full path is closed, say this path it is closed, no return. So, it will not be able to return, it will not be able to return also. Do you understand? Not unpredictable. You see this, you have operated this one. So, oil can go this way, it can return, and oil can come from this way and it can go back to tank if it is in the neutral position. But if you immediately put in these positions, this oil is connected to here, but this oil cannot go back to the tank, rather it will try to circulate, means there is no volume displacement, there is no scope, the full path is filled with oil and it is locked. So, it is a braking condition, but you should not say no operation. It has returned up to some length and then suddenly you have stopped. So, it will be in locked positions, brake positions. Okay. So, I think this is the end of the circuit, and this is, there is no reference. I have not seen this article in any book, one or two circuits only. These circuits I have collected from an article, even if there is no clue it is from which journal, and it is from that article. This is I have written what was written there, and this analysis I have done of my own obviously, but I think it is correct, and but still I request you to please try to understand, go through the exercise and find out what are the real possibilities. Before writing unpredictable, you should think twice. Okay, thank you.